We're going to start. Thanks for coming. I want to first start by announcing a whole lot of things that are happening this week. We thought that after spring break things would slow down here a little bit, but actually we have a pretty packed week already this week. So tonight, after this lecture, we have the LDS RAMP reception. RAMP is our Rice Architecture Mentoring Program, which is run by students Scott Key, Isabella Marcatilli, Jenny Zahn, faculty members Will Kennedy, Sarah Stevens, and then alumni Robert Taylor and Dave Chapman. And so the mentoring program, which has been a pretty amazing success, is having the reception afterwards along with the LDS, and I'll explain that in a second. Thursday, we have an insider trading lecture with landscape architect and professor of landscape architecture Günter Vogt, coming to us from Zurich, he's passing through town, so we're snatching him, getting him for an hour to speak at noon about landscape architecture, and Mark Lee will moderate that. That's here in Farish, and we will indeed be serving you lunch. Friday, so it's like, food tonight, food on Thursday. Friday at 5:30 we have a RAMP conversation, which will have snacks. In Farish, here in Farish with Blair Payson, who graduated in 1999 with a Bachelor of the Arc, and he's now working for Olsen Kundig Architects in Seattle, so he'll talk to us about that. And then Saturday is ArchiArts. Isabella, June, and Melis have already emailed you all about that. There's going to be a reception and exhibition from 8 to 10 here in Farish, and apparently that's going to be quite swanky. The translation of swanky is well-dressed people, and Prosecco and chocolate-dipped strawberries kind of swanky. So that's going to be a nice reception here from 8 to 10, and then the party, which I think will be swanky but also hip, will be in the courtyard from 10 to I'm not sure when. I will be on the other side of the globe, escaping that. But faculty are actually invited, I've been told, so the rest of the faculty can go. So tonight's lecture by Gregg Pasquarelli is the third of our annual Llewellyn Davies Sani Innovative Practice Lectures. We had Fred Dust of IDEO here last year and Liz Diller from Diller Scovidio Renfro the year prior. And before we start, I'd like to take a moment to thank Randir Sani, who got his MArch in urban design here in 1971, for making this series possible. So can you stand up for a second, Randir? Now, innovative practice could really be understood as a tagline for the school right now. In short, I think that we should all be taking full advantage of the fact that our university setting offers us a think tank for researching how to push architecture forward. In much the way that we might imagine our colleagues in the natural science labs on campus researching vaccines that don't yet exist, we should be taking advantage of the fact that we don't have the pressures of the market or of clients to compromise our architectural innovations. At the same time, if we pretend that those pressures don't exist at all, our innovations or our advances will have zero impact. It would be like developing a vaccine that really has no way of being administered. It would be fairly useless. So our challenge, which is exactly how we pitch the totalization studios in the option sequence, but really which should characterize every studio, our challenge is how to innovate while teetering just on the cusp of reality. How do we teach you all to learn what the realities are of our field, not so that you become frozen by the number of constraints that really do exist out there, but so that you learn how to look at architecture's particular reality just a little bit sideways, so as to see architecture in a new light, pushing it in ever newer directions. To do so requires being incredibly organized and precise, but also incredibly agile and nimble. Gregg Pasquarelli is one of 7 partners at SHOP, a firm based in New York and a firm that we're happy to have as one of our preceptorship firms. Gregg promises to tell us all about Wages-Song's progress there this year, if he doesn't have other things to talk about. As Gregg is fond of underscoring, the partners came to SHOP, they first came to architecture, specifically to Columbia's Graduate School of Architecture, Preservation, and Planning, but we'll forgive them that choice, The 5 original partners came to Columbia from different disciplines, from political science, art, engineering, history, and finance. Gregg's own undergraduate degree was from Villanova in finance. In short, the firm embodies the refrain you're surely tired of hearing me say, which is that architecture is a generalist discipline whereby we each have to take advantage of the breadth of our field in order to forge the depth of our particular expertise. We have to be precise and agile both. Shop's projects succeed in taking all the challenges that we face as architects, the challenges of materials, of construction, of financing, of politics, and of convincing clients to take a chance on something new. They take all of these challenges slightly sideways, resulting in projects that each advance architecture's practice. Please join me in inviting Gregg to the podium with the hope that by the end of his talk, all of us will be seeing sideways in the most productive of ways. And if not, by then, please join us for the reception afterwards, where refreshments might do the trick. Welcome.
Is this working? Hold on. Okay. Thank you, Sarah, very, very much. It's very nice to be down at Rice. I don't think I've lectured here in about 6 or 7 years at least. But I will let you know from the front lines in New York City that everyone is talking about this school. And Sarah's leadership and the faculty here are doing an amazing job. And the 2 people that we've had in the office are also doing an amazing job from the preceptorship program. So it's really an honor for me to be here tonight. So, yep, Shop. So it came. I'll just go right into it. So the name originally came from our last names, Sharpless, Holden, Pasquarelli, which we left here, which gave us Shop. But there are actually 5 founding partners, and that's because our partnership is made up of 2 married couples and the identical twin brother to one of the husbands. So this confused all of our clients so much that we made this chart to explain it to them. So all 5 of us went to Columbia. So Chris graduated in 1990. The rest of us graduated in 1994. And if you're inside the sort of green box, you're married and share things like bank accounts. And if you're in the blue circle, you're identical twins, and you share things like genetic code. But I think, as Sarah pointed out, that one of the things that I think is interesting to us was that we all came to architecture as a second career. And not that that's so important, good, bad, that wasn't it, but I think what it did was it allowed us to try and freely adapt other methods of problem solving and bring them to architecture and design. And among our staff, we also try to look for people who have varied backgrounds and different kinds of education and try to bring that difference to the sort of think tank of architecture. In 2007, a lot of our practice really kind of developed not only as designers but builders. It was always incredibly important for us to do both, and a 6th partner was added in 2007, John Malley, who was actually our first employee, who runs Shop Construction. And then just exactly a year ago this month, we added a 7th partner, Vishan Chakrabarty, and I was very thrilled because I found my twin to join, which is clear because both of our names have 11 letters and end in I. You know, a lot of the way that the 5 of us came together at the beginning was really about a kind of criticism of the way in which practice was being thought of. And, you know, this is sort of the last 150 years of architectural history of practice. You know, the problem was this kind of split in the last 30 years. This idea that, and our faculty actually said things like this to us, like, you guys are really great designers, you're doing interesting stuff, like, so you're going to teach and do competitions and be paper architects and write and that kind of stuff, or like, do you want to go work for a big corporate firm and learn how to actually build buildings? And we were really kind of frustrated in the fact that there was a choice, that you couldn't do both. I think in the next 20 years, some of that rift is starting to heal, but it's a wound that I think needs a lot of attention and something that needs to be pushed to try and think that in another way. I think also that we were a little bit confused by this sort of cycle of stylistic consumption. This idea that there's a theory and then an aesthetic was attached to it, and then it got a show at MoMA, and then like 3 buildings got built, and then it was sort of derided, and it went away, and then the next ism was in. And we sort of saw that as a little bit more like fashion, and that architecture is a really kind of, if not permanent thing, something that's a lot longer range in the way one thinks about what it takes to build a building. And I mean, we know it's like a lot of our buildings now take 6, 7, 8, 9 years to get going, and then hopefully are there for 50 or 100 or 200 years moving forward. So I think that what brought us together was not really an aesthetic sense, but really an idea that we wanted to rethink the way architectural practice could be thought of, and that you could both be a kind of guardian of culture and a firm that could execute at the highest level with the most complex projects out there, and that bringing those two things together, a kind of little joke about both and in the Venturi sense, but that there was this sense of a new kind of firm, and that it was possible to do both. So tonight what I'm going to show you is a few projects from early in our career and how a young office started to think about these things, and then how that grew over the 10 years to some of our current work. So if there was no aesthetic, by the way, it's kind of fun to have our monograph here. I feel like I should swear on it or something. I promise I'm telling the truth as I tell it.
I would have held it up, but it's awfully heavy.
It's too heavy. So again, there's this idea of, well, what would the aesthetic be? What would be the ways that we would engage design? And I think for us, very early, we were thinking about this notion of performance-based design, this sort of relationship of form and performance, the way things work, the way they develop, and what kind of things they were good at. It was something that was of interest to us. Now, at the same time, the computers right at that moment were becoming fast enough and inexpensive enough that they weren't only used for the aerospace industry or the biotech industry, but architects could actually afford them. And a lot of the sort of parametric modeling that we were doing a decade ago was sort of delivering projects that had a lot of complex curvature. And so very early we were trying to think, well, how do we build this? And obviously there's a long history of complex curvature in architecture, but it's always been executed, or mostly been executed through labor. People sitting with giant stones and carving out these, incredibly complex forms. So obviously we can't use labor today to do that kind of thing. But we also looked at every time that there were technological changes, and the way in which that sort of materiality was adapted, and the way in which the kind of change of technology, execution, and aesthetic kind of had these significant jumps as we were moving forward. And so a lot of these things were very interesting to us. And the more that we thought about it, the more we started to think about how do these things get made, and what is the relationship between drawing, fabrication, ornament, and effect. And as we started to draw some of the early projects, and I'll talk about this a little bit, but we started to realize that as we were engaging new technologies to actually build buildings, that often the standard idea of plan, section, and elevation were no longer effective drawing methods. That in fact, we have to start thinking about new kinds of drawings. Drawings that explain how things get built, that think about things in time, how things get assembled, and really rethink the whole process of communicating what the vision is as an architect working with an owner, and thinking about how that building is going to be executed by the people that put it together. So this is the only drawing in the AIA documents. And Shop will contend that we believe this is the single worst drawing in architectural history. That this is not a drawing by architects, that this is a drawing that doesn't serve any of the 3 major players well. And we believe that this is really a drawing that was developed by lawyers who wanted to ensure that they had work for the rest of their lives. This is a drawing that sets up a kind of acrimonious relationship that is not about inventing things together and pushing things forward, but about not taking risk, or certain people taking risk and others not, and about setting people up for blame. And it's just not what we believed architecture could be, or working with our clients the way it could be, and working with our contractors the way it could be. And so early on, as a very young office, we just tried thinking about different ways, starting with bringing consultants in, not after we had an aesthetic object built to say, how do I now translate this, but to actually learn the parameters of the way in which materials are used, things are delivered, executed, put together, and use those kinds of ideas as actually a driving force for the aesthetic from the first moment. So literally talking to people about how it would go together before there was ever anything on the page or screen. So a very early project that we did was the Young Architects. We won the Young Architects Prize with the Museum of Modern Art and PS1 back in 2000. And the program, again, this idea of performance-based design, the program was to make an urban beach. That was what we were told. So we said, well, do you need sand and water to make an urban beach? And our argument was if you had shading areas, changing areas, seating areas, dancing areas, and areas to get wet, that in fact you would have a beach without necessarily having sand and water. So the idea of the architecture was to take a series of surfaces and mutate those surfaces so that every one of the programs actually emerges on the form itself. This was the model of the structure that we proposed, and we used a kind of A-B system of sticks that went together. And then the spline were the connection points between the two sticks, and we moved the splines and manipulated them three-dimensionally so that all of those programs would emerge on the thickness of the structure itself. So this is the complete set of construction documents. That's not blurry. Each one of these drawings was 32 feet long and 15 feet high, full-scale templates that were put down on platforms. And then the people putting it together, who were architecture people who worked in our office, would just follow a color-coded system, cross the two pieces of sticks, hit it with a stainless steel screw, and trim off the two elements and move on to the next slot. And then there are numbers at the bottom that gave you the Z coordinates for where things would be placed in the courtyard. So here you can see the pieces going together, and within a matter of 3 weeks, the structure was done. So this was a budget of $50,000 to do 6,000 square feet, so a very limited budget. We had 3 weeks to design it and 3 weeks to build it. And some of the other things we developed was a product line of urban beach gear with the MoMA and PS1 logo on it. We did a forest of steel trees through the courtyard so that every half hour the high-pressure mister heads would blast a kind of fog through the entire courtyard. So as you were lying there sunning yourself, you would get hit with the spray of the ocean. And you can see the kind of smooth transition in programmatic elements from seats to walls. And your typical day at Dunescape at PS1. So for those of you who may not know, I'm sure many of you are familiar with this prize at this point, but basically it's an architectural structure for a young American architect, and then every Saturday they hold a party where they fly the best DJs in from around the world, and there's this sort of great event. Now, the year before we did the project, an architect named Philip Johnson had done the structure at PS1 and did the installation piece. Did this really cool tower element, and it was kind of great. We were the first young architect to win the prize. And you know, it was very popular. We did very well. We had 60 articles, several television appearances. And at the end of the summer, knowing it was going to be disassembled, I was sitting there looking at the crowd and people dancing and having a good time. And I asked the director of the museum, I said, so how did you guys do? And they said, it was fantastic. They said, last summer we had 2,000 people every weekend, and this year we averaged 8,000 people every weekend. And I sat there and I was like, that's interesting. So 6,000 additional people at $10 admission per person, plus the average of 2 hot dogs and a couple of beers. We just generated $1 million of revenue for the museum, and our fee was $15,000. What's wrong with architecture? So there were some really great things about it, though. Richard Branson came to see it and hired us to do work for him at Virgin, where we were able to sort of push the same limits of CNC fabrication into a sort of pavilion inside Kennedy Airport. We got our first commission for a cultural building in the Hari Valley outside of Seoul, Korea, which was an amazing sort of bookstore, museum, exhibition hall that got built, and really taught us how to think about drawings where we wouldn't be able to be right on top of the construction through the whole process. to a competition we won to do a new academic building for FIT, the Fashion Institute of Technology in New York, which it was an amazing project where the entire facade of the building became a kind of thickened envelope where the performance of design school would happen inside the facade itself. So like an amazing ant farm that you could watch everyone doing their crits, exhibiting their work, and circulating their ideas. But to build a kind of facade like this, we really had to engage in the construction more and more. And what we realized very early on was that we weren't going to get the sort of Frank Gehry budgets, if you will, as a bunch of young 30-somethings with a new practice. So we had to think about how could we use technology, something that we were really good at, to kind of circumvent the system, to figure out ways to make capital A, first-class architecture, but at very, very standardized budgets. And so the more that we did that, the more we realized we had to engage in construction. We had to learn how it was being done on the other side, or our projects would continually be value engineered. So one of the first times that we got very much involved in it was for a competition that we won to do a park in Greenport, New York, which is on the eastern end of Long Island. It's where you catch the ferry to Shelter Island and to the Hamptons. And the park had a series of elements: a carousel house, the town had an antique carousel, an amphitheater, a marina, a harbor walk, a water park, a ferry terminal, a series of other elements. And then there's one little piece here which was actually one of the last buildings built, which was a folly in the park. That was a camera obscura, that the mayor of the town really wanted a camera obscura. So here you can see the park as it got done. The carousel house has these sort of moving walls that open and close depending on the building actually responds to the microclimate on the site. Here you can see the ferry terminal, and you can see the sort of water park. We reused our Mr. heads from PS1 and brought them back out and used them there. But for this folly, we got to the point where the client had a lot of trust in us, and we said, look, we really want to do an experimental building. It's a small building, but we have this idea that could we write software that would actually produce a building that's a pure performance envelope of what the program is, see what kind of parts would come from that modeling, and see if we could have the entire building fabricated by a computer. So all the sort of elements, programmatic elements, were fed in. There was this kind of minimum surface volume that developed from it. Obviously, these were the sort of elements that it could look at from the camera, and it would use a mirror and a lens and project the image straight down onto a table in the middle of the dark room. And then this was the object that sort of emerged from that research. And we like to call this BIM version 0.1, because this is 5 years before Revit came out. But what we did was we actually just physically modeled all 2,800 parts in the model. And then we began to make a series of drawings that showed how the pieces would both be fabricated and then assembled. So this is the actual construction documents, where every different material is shown where it's placed three-dimensionally in space. And the drawings were either drawings that explained to the computer how to fabricate every part, or a drawing that showed contractors how to take all those parts and assemble them into the component pieces. And we were even able to get down to the point where we knew that the heaviest piece of a component part that would be assembled was never too much than what 2 men could lift at a time to eliminate any specialized equipment on the site. So the funny thing is, these are the drawings. It was a 20-page set. It has, fold, weld, bolt, screw. Like, these are the instructions. And when we didn't even realize it, but when we got done making the set of drawings, we looked at it, and there were no dimension strings anywhere on the drawings, because dimensions were now no longer important. Every single part was produced by the computer, arrived on the site, pre-cut, pre-slotted, pre-numbered, pre-drilled, ready to go together like the most kick-ass piece of IKEA furniture you have ever seen. So here you can see, this is actually a model we did for the Cooper Hewitt Triennial years later, where we actually took the same drawings and had it printed at 1/10 the scale and assembled it as an art piece. But even the formwork for the foundations were CNC milled. There were full-scale templates that showed the workers where to dig. And all of the instructions for how to put it together were literally laser cut into the material. Like weld, 3/4 inch fillet weld here from this length to this length was laser cut in so that they never had to really refer to the drawings. They followed number sequences and put it together. And 3 guys put the building together in about 6 weeks. And it went perfectly together, and it was an amazing experiment for us. Now, we would never argue, ever, that you would build a 60-story building or a very large building in an entire method like this. But what we did learn was that there are certain parts of a building that you could start to think in a new way. And somehow by doing those very critical elements in a really smart way, you can keep the cost down, you could get more architecture, and you can sort of raise the whole sort of feeling of the building in a strategic way. So here you can see it on the site. And the more we were doing this, the more we were realizing that we were doing things very much the way the aerospace industry was putting things together. And so in a lot of ways, we take a lot of things and share a lot of things with aerospace in the way that we think about the production of space and materials. And here's the park as it got finished. Again, a 9-year project with all public money, and something that has literally turned the town around. That led us to a competition to do a 2-mile esplanade in Lower Manhattan. So from the Battery, through Wall Street, through the South Street Seaport, and into the Lower East Side. It's a very tricky site because you have an elevated highway running through the site. And this is sort of the condition. You've got these incredible, difficult sort of infrastructure breaking the links. You've got, underneath the highway, they were using it for parking and garbage and salt piles. There are beautiful 18th century squares that were used as parking lots. And then there were places here's sort of moderate and low-income housing, people that have very little public open space. Here you have a river and waterfront, and there were places where we counted up to 14 layers of chain link fence between people, where they were living and where they could get to open space. So the first thing that we did was we leased a helicopter, and we had them fly us over the 400 miles of waterfront property of the 5 boroughs of New York to develop a taxonomy of waterfront types, and started studying the methodologies where the buildings, where the city gets closest to the water, and what the kind of performative elements were that enabled that waterfront to come alive. So the current condition down on the in Lower Manhattan was Water Street, which is a successful sort of bustling street. You have a kind of service street, front street behind, and then you have South Street that has the sort of highway, the FDR Drive floating above, parking underneath, fences, and then a lot of the piers had sheds on it, and it was just sort of impossible to get people to move there. Although the most critical thing that we learned was that the reason people weren't going over there was because of the distance between this curb and that curb. The sort of unmitigated, if you will, this sort of large expanse under a highway without signals. It was dark, it was scary, people didn't use it. So what we said to the city of New York was, look, get rid of the parking of the buses and the trucks. Anywhere you can add trees, continue the bike lane, which is circumventing the entire island of Manhattan. And instead of complaining about the FDR Drive floating above your space, try and think of it as a free roof. Think of it as this roof that you can now hang sort of lightweight walls, and you could begin to put program of the city out on the esplanade itself. You could start to have cultural elements, you could have recreational elements, and you could have community programming as well. And so the basic plan was to put those pavilions under the FDR Drive, narrow South Street so that one could cross it. And then on the piers, whenever we had an opportunity, you're not allowed to expand the footprint of the piers because of the additional shading causes environmental issues to the river. So we said instead, why don't we just try to make double-decker piers so that you get a kind of 2-for-1 of open space in a city that's starved for open space without affecting the environmental and ecological balance. So we won the competition and worked again for probably about 7 years on this project. And the first sections opened last year. So you can see we did a whole series of custom furniture with ductile concrete, with sort of this kind of crate idea. This is where the trading of the Port of New York started. We put precast concrete walls that allowed us to build up soil so that we could plant trees. Here you can see if you're under the FDR Drive looking out towards the water, the kind of lushness that we were able to get and furniture types. Now, one of the things that always sort of bothered me when I would walk on an esplanade is the fact that when you sit on a chair on an esplanade, the 42-inch required handrail height is exactly where your eyes want to look at the water. So I spent 3 years fighting with the city to convince them that all seats needed to be bar stools in front of the railing. And you can see the railing of the park actually widens from 6 inches to 18 inches. You sit up really high. You can flip open your laptop. You can open the New York Times. You can have lunch. You can talk to your friends. And you're up high and on the rail. So those are now the most popular seats in the park. And the city wants to replicate these all along the 2 miles. And we're even using it in some other projects right now. But it was a really fun thing to do. So here's your student, here's Weija, and Weija has been working for a year with us, and has actually become one of the designers of the next phases of the park, and has been out there doing construction administration and working things, but is actually designing public space in New York. She's got several pieces that have gone through the client approval process, and when she comes back next year to New York, as we hope, she will have built work in the city of New York. So we're incredibly proud of all the work she's done. If you look above, though, there's one thing is we convinced the city to paint the main girder of the FDR Drive lavender. Why lavender? That was what they kept asking us. And we said, well, one of the ideas when you come down to a waterfront, it's really important that there aren't bright lights, because one of the magical things, especially at night, of going to the waterfront is the sort of darkness that comes in, and you look out and you can see the boats on the water, you can see the moon rippling on the reflections of the waves. And even in an urban environment, we wanted to make sure that it was safe, but had that kind of magical quality. So what we did was we proposed that no lighting would ever be visible, no light source. And we buried the lights up inside this girder, where you can, inside the FDR, where you can't see it, and they literally shine onto the lavender girder, and then that light comes out and casts this sort of beautiful glow on the esplanade. And it's incredibly romantic out there, and everyone says that if you go out there on a date, everyone makes out and have a good time. So it works. You can see even the lights inside the retaining walls hit these sort of angles and cast the light on the ground so that it's safe to walk. And then on our double-decker Pier 15, you can see we had these series of glass pavilions that have lawns on their roofs, green roofs, that hold up this sort of flying wing above. And there are planters on the pier that open up to the sunlight. We use the same kind of furniture and railing. Here you can see from the upper deck, so literally this is a cafe space, and there's another one that's a waterfront, a sort of marine habitat learning center for the kids in the local schools, with a green roof on the top that becomes lawns that people can sit on and picnic on. Here you can see, so this is basically completely invented space in New York. Now it's remarkable because the sort of incremental cost of making that second floor was really quite small to get an extra 60,000 feet of open space in New York. I mean, we were able to produce it for like $150 a foot, where, open land in New York is what could be worth $5,000, $10,000 a foot. So it was a remarkable thing that the city is very happy about, and the neighborhood absolutely loves. So here you can see we have places where you can get down close to the water. Here's Weija again doing CA. And then in order to not make you, so one of the concerns was that you have this big overhang on top of you, it sort of makes it dark underneath. So we used a series of these sort of flowing stick elements with lights up inside that sort of reflect off the structure above. And this is what the pier looks like on a typical night. So it's been incredibly well received and incredibly well used. And these are the first 2 phases of a 6-phase project that will take probably another 4 years to complete the 1.8 miles. So doing this project was very interesting because there's the South Street Seaport sits right here in this location, which was an old Rouse development from the 80s that has not fared very well over time. and at the time was owned by General Growth Properties, a mall REIT, a national mall REIT, and they came to us because they saw what we were doing on the East River, and they said, would you help us re-envision what could be done here at the South Street Seaport? So we proposed moving the historic market buildings out to the end, working with James Corner of Field Ops. We did a 4-acre park in the middle, and then proposed shifting all of the FAR into a kind of tall, slender building. So it was an interesting mixed-use project where you had layers of retail, hotel, and residential above, and the proposed tower was an exoskeleton that was clad in terracotta with these 3 sort of floating volumes of glass that were almost sail-like in the structure itself. General Growth in 2009 actually went through a bankruptcy. The company reemerged, split, and now the Howard Hughes Corporation has taken over the project, hired us again, and we're working on the first phase of a multi-phase project for what could be done down here. And so this is one of the current designs. Anna Lee, who was with us last year, worked on this project as well. But again, it's this idea of a kind of village of retail above, mixed-use spaces on top, and then an outdoor amphitheater. We used Tanglewood as our model of having a sort of smaller concert hall that you could have cultural events that opens up onto a 2.5-acre lawn, 500 feet out on the water, 60 feet up in front of the Brooklyn Bridge. So you can see carving into the pier where boats could pull right into the retail area. The cultural venues would be above. And this project, we are about a month away from getting, this had to go through a rezoning, we're about a month away from getting our approval on it. We'll start construction in June. And then working on that, we got to meet and work with the mayor of New York, and Michael Bloomberg asked us, put us on a short list to do his European headquarters in London. Amazing project. We were up against some of the top architects in the world. It started with 5, it went down to 2, and this was our proposal. It was a very tricky project, and programmatically and also dealing with the London sort of codes, but it was this idea of a media company connecting to its location, connecting to the street, the kinds of ways in which the company would work around these volumes that cut through the building, and then how it would be read as a kind of sculptural element floating on the skyline. This would be the view from standing on the terrace at the Tate Modern, looking north across the Thames. So it came down to us and Norman Foster, and we battled and battled and battled, and Norman got the best of us in London. But no shame of losing to Lord Foster in London. Although we were very disappointed, of course. I promise I'm still not upset about it. But you know, it was very interesting as we were just continuing to learn about the ways we were solving problems for our clients, and thinking about design, thinking about the difference between development and design, and public space and design, and institutions and design, and those different elements. And you know, design, we think, is just incredibly good business, and it's just really smart to do good design. But we were also trying to think, like, is there a way that if we wanted to push the limits of how we were thinking about design and architecture and execution, should we begin to take take equity positions in some of our projects? Should we almost start to be partly the client? And if we were, would there be different models in which we could execute buildings? Would it make a big difference? And you know, this is a little trick that we call the cycle of mediocrity. And you know, we love working with developers. I think it's really interesting, but there's sometimes where you have to push it. And I think sometimes people could be critical of many developer buildings. But really what we learned was the issue wasn't really the developer. The issue was the lender. And the problem is that in order to get someone to underwrite your building, they typically ask for the comps, right? What are the comparables? What are the 5 buildings designed in this exact same way with the same materials, details, in the same neighborhood, and what do they cost and what do they sell for? And if it all pencils out, they'll underwrite the building. Well, that's kind of tough to do if the comparables were only what came out of the product that was available, which was the only thing the brokers really had to sell, which was the only choice the purchaser had to buy, which generated some sort of sales data that told the marketing team what you needed, which then pushed the designers into sort of doing the same thing over and over again. So for us, we started thinking about this relationship right here, and would there be a way to take sort of progressive and innovative ideas about building and design and push the model a little bit forward. So the first time that we did that was a building called the Porter House in the Meatpacking District of New York. And we actually found a 6-story warehouse building that was for sale. It was a furniture manufacturer. It had, there were 2 historic buildings to the south of it, and the FAR in this area was 6, so the building had used all of its FAR. And there were lots of guys chasing this property. So the first thing that we thought of was to negotiate an air rights transfer, to actually buy the rights of the space from the buildings below, put them on top. There was a 120-foot height limit and a 15-foot setback required by code. And, you know, a few less people had that idea. But in order to sort of outbid the other people going after the dirt, we just figured we had to try and expand the size of the building as much as we could. Because by expanding it, theoretically, there would be a little bit more to sell, a little bit more revenue that's down the road that would give us a little bit more money to try and outbid to control the property. So this has become more common in New York, but when we did this, it really wasn't that common, where we bought an air and light easement over the 2 buildings and started to push the building horizontally to increase its size. And now the problem is, the more that you push that cantilever out, you sort of have a diminishing return because the cantilever becomes very expensive and it sort of offsets the additional revenue. So working with Bureau-Happold engineers, we came up with a very clever way of sort of taking a historic 6-story building and linking it with a brand new 6-story building with a 2-story couple that went through the floors, and then we put a new core in the middle that, using mini piles drilled 90 feet down into bedrock, kept the building from turning over in a very efficient way. And we were able to get that cantilever out just a couple more feet, which gave us just a little bit more money, so that we were the ones who won the project. We joint ventured with one of our clients. We couldn't pull the whole thing off ourselves, but it was a fantastic learning experience. We moved the core to the middle of the building. These are just typical layouts. They're all fairly large apartments. They all have 3 exposures. And then we had this sort of very new building on top of a historic building. And the idea was, contextuality was that it should not look anything like the building next to it. And we wanted to test a new material. So we wanted to build it out. We wanted to try a metal skin. So we wanted to do zinc, a material that's a kind of natural material. And we went to the facade manufacturers, and they told us that the zinc was going to be this very expensive price, and it didn't make any sense to us. We were like, well, zinc only costs about 15% more than steel, and the material is only half of the whole budget. Why should it be double the price? And they said, well, that's just what the price is. So we asked them, well, where does zinc come from? And they said, mostly it comes from France. And so we got on an airplane and we went to France, and we bought 1,000 sheets of zinc and brought them back to New York. And what we did was we took the 1 meter by 3 meter pieces of raw material, and we designed the entire building around the unfolded panels of fitting 1 on a sheet, 2 on a sheet, or 3 on a sheet. We had about 22 proto shapes that we needed, about 450 different shapes in total, and about 4,000 pieces of zinc in all. Now, to do 450 shop drawings of all this would have killed us. We were a little firm. We were just trying to figure out how to do it, and it probably wouldn't have been that accurate. So it was the first time that we went to SolidWorks, where we made one sort of parametric piece and fed all the difference in through a spreadsheet that went directly to the laser cutters that cut the parts. So the 4,000 panels were cut. They were all given a kind of code system that was laser cut right into the facade itself, which became the instruction set for putting the building together. So the panels arrived, they knew where to lay them out, they put them onto the building, and that code is still there. So one of the architectural details is actually the instruction set. We started at one end of the box, we went all the way around with the 4,000 pieces, and when we got back to the middle, we were 1/32 of an inch off, with no shop drawings whatsoever. And we said, oh, by the way, we brought it in at 30% under budget. And we said, this is a good idea. We should do more of it. So one of the things I love about the building is the kind of the shape and the contrast between the two. You have these large floor-to-ceiling windows. There are 4 sizes of the windows, 3 sizes of the panels, and then 2 sizes of these white boxes that become these light boxes that glow on the facade at night. Here you can see the integration between the old and the new building with setback terraces. And we pushed all of the glazing back 14 inches, and that was really important to us. We didn't think of this building as a sort of taut skin. We really wanted it to have a play of light and shadow. Now, the problem with pushing the glass back 14 inches is that you suddenly create ledges, and in New York we have a pigeon issue. So we called the Museum of Natural History, and we asked them, is there an angle of repose that a pigeon will not land on? And they said, in fact, it's 34 degrees. So every one of our drawings, we have this angled 35-degree angled element. In our code system, it's labeled PS, 226, whichever one it is, which stands for pigeon slide. And in fact, what's remarkable is, it's up there, and like you actually see sometimes the pigeons will come and they'll land, and they go right off. And I'm incredibly proud that 10 years later, there's not a single turd on the facade of the courthouse. We did the collateral materials, we did the interiors, we brought it to market, and we sold at about 17% higher than our 3 competitors from other top architects at the time. And it was remarkable for us because we really saw that when we were engaged and understood that every move we were making from a design aspect had an impact on the pro forma, and we really respected and understood that kind of back and forth, that a lot of our colleagues at the time, the people that I was teaching with at Columbia, were saying like, gosh, like it's kind of a slippery slope. You're working with developers and joint venturing, and we were saying like, why? Why do you think that way about it? And you're going to lose your design freedom. And what we found was the more engaged we are, the more we were connected to the financial models and the technological models, the more design freedom we actually had. Because our interests were aligned, and we were able to sort of take some risks and think about it and underwrite those risks and discuss it in a way that really allowed us to push design to a new level for us. So it was a great building. This is taken just a few months ago. It still looks great, and it's one of the hot buildings still in New York, trading today. It's led to. This is an image that just got released yesterday. I didn't know I was allowed to talk about it, but until yesterday. So this is it's led to other large-scale developer buildings for people like Related and Forest City. And this is Two Trees, who are the people that invented the Dumbo neighborhood of New York. This is the Domino sugar plant in Williamsburg on the East River. And so the client came to us 6 months ago and asked us to re-envision this entire 3 million square foot mixed-use project. One of the key things we did that the previous plan didn't, the previous plan had all cul-de-sacs with sort of lumpier buildings in the middle that were much lower and more contextual, traditional. And we said, look, we really believe that innovative building types and thinking about the way light would pass through these buildings and what it would be like to be on these smaller streets and look through to the river, and putting a street along the front which made this park public and not private was really a smart way to go. So this got rolled out yesterday, and there's already been about a dozen articles really, even though our buildings, which went from 400 feet to 600 feet, which usually in New York starts a complete firestorm of protest, in fact, it's an unbelievable outpouring of support. So we'll have to go through a rezoning, but our client is willing to take on the chance, and we're incredibly excited about the opportunity and the way in which this is the historic building, the way in which this public space will get built and to really push these buildings. So that came out at 9 o'clock yesterday morning. By 5 o'clock, I don't know how many of you are familiar with Curbed.com, the blog about real estate development and architecture. By 5 o'clock, the word was that we were getting way too many projects in New York. We've got 6 of the biggest projects going on right now, and this is how they redrew our project to have SHOP in there. But I think it was all done in very good fun. So there were other times where a client just asked us to be a consultant in a different way, to rethink the way that they were thinking about their business. So a very large internet search engine company approached us and asked us to rethink what the American workplace would be like. And so but they were guys that really were interested in the way code was written, and they couldn't understand architecture and space quite as much. So they wanted a very progressive building. They said LEED Platinum, if we produced a LEED Platinum building, it was a total failure. They wanted 2 generations beyond LEED Platinum, and then what would that be? And we talked about sort of form and performance and this performance wing, and there was this whole strategy of how to get it done. But we actually wrote our own software where we were able to show them that depending on how they prioritize their needs, literally hundreds of different morphologies of buildings would be developed. And it wasn't until they understood that relationship by actually reading the code that they started to understand space and architecture. So it was an amazing project to think about and to work on for a few years. This was the building we eventually produced for them. This was going to be their first ground-up building. It has an amphitheater that's outdoors and indoors for their 5,000 employees in this location. The way that the ramps and the seating work, the whole kind of way in which the environmental systems work was incredibly progressive. Was all a base isolation system. I mean, it was really a fascinating project. One that unfortunately got done in by the crash in 2008 and 9. But a lot of the research that we took from that, we applied to a competition that we did in Botswana, Africa, for a new government complex. And so we took the 2 sort of main landforms of Botswana, the Dune and the Delta, and used it as a kind of way to divide up a site for a new innovation hub. Botswana is a fascinating country. It's basically the same land size as France, but only has 2 million people, and 35% of all the property is national park, with unbelievable diamond wealth and a stable democracy for 45 years. They attribute it to the fact that they discovered the diamonds after the Europeans were out. So they're fantastic, progressive, forward-thinking. This was the competition entry for the building. It came down to Norman Foster and Shop again, and fortunately this one wasn't in London, and we were able to just get lucky enough to win. But one of the things that I love about the project is there's beautiful more than 100-year-old trees, and we burned everything up. That parking has to be covered and cut holes in the public space so that the trees come up from the parking lot and become the sort of shading devices on the interior, on the inside-outside gathering spaces. And then a series of glass bridges go through the treetops connecting the different elements. There's a tremendous amount of, again, like sort of eco-tech and environmental modeling that really pushed the way the facade would work. These are our, the parametric models. We use sort of traditional Botswanan basket weaving techniques to become the sort of walls and systems in the public spaces. Sort of working on a whole knowledge transfer system with their university down there, showing them how to use these softwares, what some of the interior spaces will look like. These are the first mock-ups of the wood walls and panels, all produced by the computer. And then a look out over the roofs, looking towards the airport and the Capitol, and what the building will look like when it's done. So they started construction on this a while ago. It was on hold for about 18 months for a series of political reasons, but fortunately it's under construction again. And we're really excited to see it go. It's a 300,000-foot building that's the heart of a 3 million square foot campus that we helped design for the government, and sort of what it would be like to be in those spaces looking out at the landscape. So this is sort of now the last part of the lecture, which is kind of the Barclays Center, the building that we just finished. A couple of projects, one of the projects that we're moving on to, and then some of our business model. But for those of you who may or may not know, the Barclays Center was one part of a 6 million square foot development at Atlantic Yards done by Forest City Ratner Corporation. Frank Geary was the master plan architect and the design architect. An incredibly contentious project, had eminent domain issues, unbelievable protests, 34 lawsuits filed against the developer, and a really ambitious architectural program. So eventually what happened was the project, the architects were switched out. The press likes to say that it was because the Frank Gehry buildings were too expensive, somehow blaming the design architect, in my opinion. And that wasn't why it got switched at all. What I think Frank did that was really quite brilliant was, for an urban arena, you know, oftentimes sports facilities really turn a back wall, a blank wall to their environment. They become this kind of dead zone. And what Gehry's office did here, I think was brilliant, was basically the arena was buried inside the bases of 4 major towers. So the way you could think about it is there were these 4 towers with huge foundations around here, and the bowl sat in the middle of those foundations, and literally 80% of the arena was not visible from the street. The problem with the project was that in 2009, when they had to finance the project, those 4 towers were unfinanceable. And so the Gehry design had to be completely rethought as a standalone object. So now, of course, it takes at least a year and a half, if not 2 years, to draw an arena. And the problem was that the tax laws were changing so that stadium bond financing was no longer tax deductible if the building hadn't started by December 31st, 2009. This was March. So our client, Bruce Ratner of Forest City, who is an amazing, amazing guy, was in a tough spot. And he went to Hunt Construction, who are sort of one of the preeminent builders, design-build firms of stadiums and arenas, and said, what do we do to get into the ground in 9 months? And they said, it's impossible to do a new one. They said, the only hope we would ever have is if we go look at every basketball arena we've ever done, and you find one that you like that fits on the site, and at least we have the steel drawings, and we can order the steel and then figure it out from there. So they went around and looked at all the buildings, and the one that they liked the most was Conseco Fieldhouse in Indianapolis. And that was done by Ellaby Beckett, now AECOM, who were then asked to just take Conseco Fieldhouse and drop it into the middle of Brooklyn. So that was the design. And they went back to the city and said, look, this is the only way we're going to do it. And as you might imagine, the city was a little bit upset, where they felt they were kind of baited and switched. And it totally was not fair to Ellaby Beckett and AECOM. They were put in a very, very difficult situation. So the whole thing was grinding to a halt, and there seemed to be a lot of problems. And I guess eventually Bruce went to David Childs, the head of SOM, and said, I don't know what I'm going to do. I've got an issue here. And David said, yeah, it's a tough one. He said, there's only one firm, I think, that can fix your problem, and that's a firm called Shop. And he said, I've never heard of them. And he was like, well, you should give them a call. So one day I was actually sitting in someone's office. I never knew Bruce. And the phone rings, and I see Bruce Ratner, Forest City. I was like, do I answer it? I don't know what to do. He said, hi, this is Greg. I said, yes, it's Bruce. He said, do you know what my problem is? I said, are you talking about Atlantic Yards? He said, yes. I'll be in your office on Monday at 5 o'clock, and you have 3 new concepts for the building by Monday. This was July 4th weekend, and it was Thursday. So he said, okay, we'll work on it. So we worked on it, and we came up with some ideas, and he came in, and we had this fantastic 3-hour meeting. But at the end of the day, what we realized, he just wanted a new skin on the building. And so we turned the commission down, and we said, that's not what we do, and we respect and understand the situation you're in. But, we just don't wrap things, and got into this great metaphorical discussion about couture dresses and other things. And literally at the end, we told him what we did. He said, you guys are great. He's like, I'm sorry it didn't work out this time. I'll call you in 3 years when this recession is over. We'll definitely do a building together. And that was it. So with my partners, we went out for some drinks and talked about the day, and it was very interesting. And then that night we had sort of one idea of how we might be able to take this steel, rework this steel. Well, then he told us that steel had already been ordered for this building, and we were like, oh God. And then we were thinking, well, what could we do, and how could we make it penetrate inside, and how could we rethink the whole building to change it performatively for something else? So we called him the next day, and we said, okay, we've got your box. I said, we'll work for 72 hours, and we'll produce 1 image, and we'll explain to you how it could get built. And in 72 hours, we'll send it back to you. If you like it, great, you hire us, but we get the whole thing, including the interiors and everything else. If you don't like it, no harm, no foul, we'll talk to you in 3 years. And he said, you do that for us? I said, yeah, we'll do it for you. So I've only shown this a few times. Well, this was the first sketch we did that night for Barclays. Now, the thing that none of us can remember at all is why the hell Toyo Ito's name is on this drawing. We don't even like Toyo. He's a nice guy, but we're like, I don't know why was Toyo Ito there? So we still don't know, and Toyo Ito had some really significant part of developing the Barclays design. But a lot of stuff, the way that the court carved into the ground, the idea of the oculus and coming out of the subway, the kind of form, the sort of different kind of entry, it was kind of there in the very first sketch. So the idea was to take it, instead of it being a kind of large vertically oriented shed, we said, let's divide the building into sort of glass, solid, void, solid, if you will. And let's turn a lot of the program to the outside, so that when the building is not being used as a sports arena, it doesn't kill the street. Which is most of the time. There's 200 events, but there's 365 days, and it's all day long. And let's really think about the entry plaza. Let's think about from the concourses how you could look out and engage the city in a different way. And then we said, and you need a kind of grand entrance. There's got to be a kind of public gesture for the way you come into this building. And for those of you who may or may not know, Jay-Z is one of the owners of the Nets. So we explained it to Bruce and everyone. We were like, look, it's a little bit of Arms of Bernini, but sort of hip hop style. And they were like, okay, let's think about this. So one of the key things was we tore open a much larger opening so that from the public space, because the court is sunk below grade, you can actually see right into the bowl and see the scoreboard. So there starts this incredibly different engagement. And then cut a hole, this oculus, in this 85-foot by 250-foot cantilever that we did as this main entry, where you come out of the subway and look up at the sky. Now, this is an incredibly complicated project. We have 11 subway lines and a train station underneath it. And you're in the middle of two of the major thoroughfares of Brooklyn. And we started thinking about, what would the aesthetic be, this kind of notion of the sort of aging industry, but the sort of art world and the culinary world that's really emerging there. The idea of technology in Brooklyn, one that's both sort of slick and rough at the same time. And this is the image that we sent him. I've only shown this maybe 3 or 4 times. This was the first drawing that we sent, and we explained how all this stuff would work, and it would turn in and would have this big entry. And we sent it in on Friday. And we figured, well, we'll hear something Monday morning. Monday passed, we didn't hear anything. Tuesday passed, and then I called the senior VP in charge of development and construction. I said, hey, did you guys ever get that image? And he's like, you have no idea how much trouble that image has caused over here. And I was like, yes, we got the project. Now what I do show you, they hired us, and they said that we had to redesign the building, detail it, and cost the delta between the original budget and this one in 7 weeks. 7 weeks. That should take 7 months. So we had 28 people working on double shifts, 12-hour shifts, working around the night. And we did the whole thing, and it came out. We had a $50 million possible delta on the project. So from a $925 million building to a $975 million building, we came in at $40 million delta, and then we got the entire job. And so this was the first image, July 10th. This was the image September 1st. And this is the building 3 years later, completely done. And I think it's kind of remarkable to watch that transformation in such a short period for such an incredibly complicated building. So how do we do it? The idea then is that the ribs. So basically the building has these ribs that come down and turn into the concourses. You have the sort of glazing at the street and the upper concourse. Here you see the oculus in the middle and the large cantilever. We redesigned the subway entrances and all the public spaces. This is like an 1.5 acre public space in front. And it was this idea of 12,000 different shaped panels of steel that are folded that make this kind of both sinuous but sort of rough industrial, sexy, sinuous shape that goes around the entire building and sort of responds with its openings based on the performance of what's happening programmatically behind it. So the rails of the steel turn in and become the ceilings in the concourses. The concourses have glass at them, so you're constantly looking out while you're in the stadium. And then we were thinking about the interiors like the sort of wet Brooklyn night, this kind of idea of the reflected floor and the darkness above and things floating in the element. So the concourses became the steel ribs come through and become the light elements. Everything is painted black with black walls with these sort of Donald Judd boxes that float into the back walls to kind of be these minimalist elements holding the concessions. There are these sort of material changes when you come to different elements, but again, trying to really push away from the typical aesthetic of a sports arena and move it something much closer to a kind of cultural facility. The main entry, some of the bars actually penetrate the bowl themselves and come out. And then the last piece was that we really strongly suggested that the entire inside of the bowl be black. Every seat needed to be black, all the walls and floors dark gray, and the argument was that sports, which I happen to be a huge sports fan, that sports is theater with an unscripted ending, and that it should feel like black box theater. It should be totally focused on what's unfolding in front of you on the court, and then that led to changing the uniforms, changing the logos, and really pushing the whole way in which the New Jersey Nets were switching to becoming Brooklyn, and a very, very different kind of vibe. And then the last element was that on the folded steel plates, we hid lights behind the panels so that they would glow, they would shine up and hit these folded elements, so you would have this sort of ethereal glow that dematerializes the building at night, because it's really in a sort of 4- and 5-story residential neighborhood, and we needed something to continue to break down the mass of the project. So, unbelievably complicated. How do you build it? Shop Construction immediately joint ventures with the facade manufacturers and with Hunt. Shop Architects is working for the client, and together we all just roll up our sleeves and say we've got to be able to solve this thing. So again, writing parametric scripts where we were able to look at the building live, moving literally from any part around the site, moving the shapes of the building, going to live models showing us our costing and our materials uses. So we can literally, sort of like plastic surgeons, push and pull everything and get an immediate number of what we were doing. You can always keep it within our budget, but push it. And that gave the client incredible trust in what we were doing. Eventually modeled in CATIA by Shop Construction, the unfolded 12,000 panels of steel. It all worked on a kind of standard sort of aluminum backer wall with these outriggers, and then each one of these panels got assembled into a mega panel. Here you can see a typical mega panel, so there were 921 of these, which were exactly the size that you could fit on a truck to get into New York City, that you could pick up and put onto the building. Those are the first mock-ups on the right. All the cut files were produced by Shop Construction, all the tickets, and then we worked with setting up a facility where all the panels were hung on this kind of dry cleaner rack, and the panels went through 15 wet-dry cycles a day for 4 months to put 10 years of rust patina on every object so that it wouldn't drip on you when it gets put in place and would have the right patina. Here you can see the rails being patinaed, all the panels. And then we tagged every single panel, and then we wrote our own iPhone app that you could go up to any panel at any time, scan it, and it would give you all the information of where it was in production, where it was shipping, where it was laid out on the site, and how it would get put up on the building itself. And this is what would come up, and you could hit any of these buttons so that anyone, from Bruce Ratner to a guy with a wrench, had the same information on the field. And that clarity and that openness was what allowed this thing to happen, in my opinion. And there's this constant sort of feedback loop of the way in which we were designing and making constantly through the process. So here they got put on a truck. And then while the steel was going up, while they were being weathered,